Assalamualaikum warahmatullahi wabarakatuh, and hi. In this video, our group Mickey Mouse will talk about the application of differentiation. Okay, this group consists of 4 members, which is Aiman, Hilmi, Aidil and Zarfan.
Okay, so for my turn, we will talk about what is differentiation. So we can call differentiation as a derivative. It has same name. So derivative is all about finding the slope. So the equation that we use to find the slope of the tangent line is this one. And then the derivative of fx with respect to x is the function of f prime x and is defined as this equation. Okay, and then what is the uses of differentiation in real life? So the number one is to calculate the profit and loss in business using the graph, and then to check the temperature variation. Other than that, to determine the speed or distance covered, such as miles per hour or kilometer per hour or etc. And then the last one in the study of seismology, like to find the range of magnitudes of the earthquake. Okay, the history about differentiation or derivative. Modern differentiation and derivative are usually credited to Isaac Newton and Gottfried Leibniz. They developed the fundamental theorem of calculus in the 17th century. This related differentiation and integration in a way which revolutionized the methods for computing area and volumes. However, Newton's work would not have been possible without the efforts of Eisenhower, who began early development of the derivative in the 16th century. That's all for me. Thank you.
So now we move to the question. Water is leaking from a tank at a rate of 4 cm³ per second. The volume of water in the tank is given by V equal to 3x² plus 24x over 2, where x is the height of water in the container. Find the rate of change at which the height of water is decreasing when the volume is 30 cm³. Step 1. Write an equation involving the variables whose rates of change either are given or are to be determined. Step 2. Using chain rule, implicitly differentiate both sides of the equation. Step 3. Substitute into the resulting equation all known values for the variables and their rates of change and solve for the required rate of change. Step 4. For the last step, we just calculate and solve the value that we already had given. That's all.
In conclusion, derivatives are constantly used in everyday life to help measure how much something is changing. They are used by the government in population census, various types of sciences, and even in economics. Knowing how to use derivatives, when to use them, and how to apply them in everyday life can be a crucial part of any profession. So learning early is always a good thing. To remind you again, this application is important for our life, but people still don't know how it works in real life. To give a simple example, the cooling of ice. We calculate change in temperature with respect to time. Similar other examples will be rate of decay of radioactive elements, rate of growth of bacteria, deformation of an element along the length, and the other else. For all such examples of the real life, differentiation is a method to calculate required values at certain points other than the ones easily measured. Most common use of derivatives is finding maximum and minimum values of a function. One might wish to calculate maximum profit, minimum loss for his business. Simulation softwares in engineering highly rely upon differential equations to solve difficult geometries. Various problems of nuclear decay, heat transfer, structural analysis involve differentiation. So that's all from us, from Mickey Mouse. Thank you.